Hello everyone. Today we'll be discussing about structuring elements in morphology. In the last class, we have introduced morphological operations in image processing, and we had a discussion about the motivation, the goal of morphological image processing, and few basic concepts in set theory. So, morphology is the science of appearance, shape, and organization. The operations of mathematical morphology were originally defined as the set operations, and these form the basis for mathematical morphology, and in the last class we have focused upon these set operations. Further, these operations are useful for processing the sets of 2D points. So, these sets are formulated by making use of the coordinates of each pixel, and thus the sets comprises of the two-dimensional points. And in mathematical morphology, we are going to process these sets of two-dimensional points. Morphological image processing is a collection of nonlinear operations. Those are related to the shape or morphology of features in an image. Morphological operations rely on the relative ordering of the pixel values. I'll repeat, these operations rely on the relative ordering of the pixel values, right? And these operations do not rely on the numerical values of the pixels, right? And that is really a very important point that we should understand related to morphological image processing operations. And as these rely on relative ordering of pixel values, these operations are especially suited for binary image processing. And that is why we are going to discuss these morphological operations. Those are meant for processing the binary images. The basic morphological operations applied to images can be used to extract the edges. So, extraction of edges is or can be done. Then we can filter the images, or the operations those we may perform using such kinds of morphological operators are like skeletonization of images. So, we will be focusing upon few basic morphological operations in this unit, and further these operations can be extended to form several morphological algorithms, right? So, with this, today we will be focusing upon one important concept under morphological image processing, and that is the structuring elements. So, what we mean by structuring elements? So, morphological techniques usually probe an image with a small shape or a template, and that is called as a structuring element and denoted as SE. So, morphological techniques usually consider a small structure, right, that includes the elements like zeros and ones, right, and that template or that small shape is used or that shape is moved throughout the image, and depending upon the operation to be performed, we are actually using those templates to process the underlying binary images to come up with the required outputs, right? So the structuring element needs to be positioned at all possible locations in the image, and that is compared with the corresponding neighborhood of the pixel. I'll repeat. The structuring element is positioned at all the possible locations in the image, and it is compared with the corresponding neighborhood of the pixel. So see here, if I am having such kind of image, right? So there are certain rows and columns, right? So similar to whatever we did with the spatial linear filters, we are having small structuring elements here, right? And we place that element such that the origin of that structuring element is placed at certain location in the image, and depending upon that we are going to compare the structuring element along with the image region occupied by that structuring element. It is being compared with the corresponding neighborhood of pixels, and the output is being generated, right? So typically operations test whether the structuring element fits within the neighborhood or whether the structuring element hits or intersects the neighborhood. What we mean by fitting the neighborhood or hitting the neighborhood? I'll explain this with one example. Let us assume that we are having this particular binary image. So this is our binary image, right? And we are having one structuring element. As I stated, structuring element is of smaller size, right? And what we are going to do is, we are going to probe this image with this particular structuring element. See here, we are assuming that whatever are the white regions in the image, right, those white regions are the zeros, right? We are talking about the binary image, right? So whatever are the white regions or white pixels here, we are assuming that these pixels are zeros, and whichever are the gray shade pixels, we are assuming that these gray shade pixels are ones, right? So what we are going to do is, this structuring element is being located everywhere onto the pixels of this binary image, and we are going to see whether the structuring element fits with the neighborhood or whether the structuring element hits or it intersects with the neighborhood. So for the sake of understanding, I am having here three regions located in this binary image. So let us assume that this is one of the locations or the regions of the image that we have identified. And what we are going to do is, we are going to position this structuring element at this location. Now at this region A, if I place the structuring element, then I'll say that the structuring element fits the image. Okay, so what I'll say that this structuring element fits the image. Is that okay? So this is fitting. I'll let you know how to define this fitting and hitting, right? But with respect to the image under consideration and the structuring element under consideration, if I place the structuring element at this location A, then I am saying that the structuring element fits the image. Okay, if I am putting this structuring element at this location B, okay, then what I'll be saying? I'll be saying that the structuring element hits or intersects the image, right? Whereas if I put this structuring element at this region C in the image, then I'll say the structuring element neither fits nor hits the image. So depending upon fitting, hitting, or not at all having any fit or hit, right, we are going to generate the output. So a morphological operation on a binary image creates a new binary image wherein the pixel has a non-zero value only if the test is successful at that location. I'll repeat. Structuring element is being positioned throughout the binary image, right? And the operation on binary image is creating the output, which is also a new binary image. Okay, now in the new binary image, my output would be non-zero value only if the test is successful at that location. Okay, and the test is depending upon whether the structuring element hits the image or whether it fits the image, right? So let us proceed with few more details, right? So as I stated, the structuring element is a small binary image. It has a small matrix of pixels having the values as zeros, ones, or don't cares. So three kinds of values we may have in the structuring element. So these are either zeros or ones or don't cares. So let us see one example of simple structuring element. So this is one structuring element. Okay, this is one structuring element. The size of the structuring element is 5 by 5, right? And we are having this pink center location of this structuring element as the origin of that structuring element, right? So in this structuring element, all the values are ones. Okay, now let us look at the second example of the structuring element. Here we are having diamond shaped 5 by 5 structuring element. So see here why we are saying that this is diamond shaped. So in this 5 by 5 structuring element, the ones are located in a diamond shape and the remaining values of the structuring element are zeros, and that is why we are saying that this is a diamond shaped structuring element with size 5 by 5. Now just look at this third structuring element. Here we are having cross shaped 5 by 5 element. So size of the structuring element once again is 5 by 5, but the elements in the cross shape are ones and remaining are zeros. And here also we can observe that the origin is the center pixel. Okay, now one more example, let us look at square 3 by 3 image. So all the pixels, or rather all the values in this 3 by 3 structuring element are ones. But here look at this origin. Origin is located at the bottom right corner. So not necessarily always the origin is at the center of the structuring element. We may have the origin at any location in the image depending upon the application. The matrix dimensions of the structuring element are specifying the size. Okay, the pattern of ones and zeros specify the shape of the structuring element. The patterns of ones and zeros specify the shape of structuring element. So this is diamond shaped, this is cross shaped. So how the zeros and ones are located in the structuring element, that denotes the shape of the structuring element, right? And the dimensionality of the matrix denotes the size of the structuring element. Then the origin of the structuring element is 1 pixel, or it is 1 pixel, or it is one of its pixels or one of its locations is designated as the origin. And as I stated, it can be located at the center of the structuring element or at any pixel in the structuring element, or it may sometimes happens that the origin is outside the structuring element. So this is also possible. Now let us go to one example wherein I am demonstrating what we mean by fitting the structuring element and hitting the structuring element. So let us consider this binary image. So this is our binary image. So you can observe here the pixels are having the 0 value or 1 value. Okay. Now once again we have identified here several regions from the image. So see here we have identified region A, region B and region C. Okay, these are the 3 by 3 regions, and we are having two structuring elements S1 and S2. So this first structuring element is having this square shape with all the ones, and the center pixel is 1. So this is having the size 3 by 3, and the shape of the structuring element is the square shape. Whereas if we look at this structuring element as S2, what we have is, once again the size of this structuring element is 3 by 3. But what is this shape of this structuring element? It is cross shaped, right? It is cross shaped, and the center pixel or the center position is the origin of this structuring element 2. Now what we are going to do is, we are making use of this structuring element S1 individually and this structuring element S2 individually to understand fitting and heating concepts. So for the sake of understanding, I am considering here only 3 regions and I will be explaining you this concept. Okay. So when the structuring element is placed in a binary image, each of its pixel is associated with the corresponding location of the neighborhood under the structuring element. So see here this structure, let us consider this structuring element S1. So this structuring element S1 is being placed, okay, on this region A. So I will be using structuring element S1 and I am saying that it is placed at this region A. So this region A of the image is overlapped with this structuring element S1. Okay. Now the structuring element is said to fit the image if for each of its pixels the corresponding image pixel is also 1. I will repeat what I mean. When I will be saying that the structuring element is said to fit the image, so structuring element is, I will be writing here the definition. The structuring element is said to fit the image if for each of its pixels, for each of its pixels set to 1, the corresponding image pixel is also 1, right? So, see here, I am putting this structuring element on this region A. Okay, so for each position of the structuring element, it is overlapped. S1 is overlapped with A. So for each of the location which is set to 1 of my structuring element, the corresponding image pixel is also 1 for all the neighborhood. So here I am having 3 by 3 neighborhood and S1 contains all ones. So whenever it is being placed over to A, right, in my region A, with respect to 1 in S1, I am having the pixel value also 1. Okay, so if this is the case, that for every 1 in my structuring element, if the underlying image is also having the pixel with value 1, then I'll say that, and if it is true for all the pixels in the structuring element, then I'll say that it is fitting. Okay, so with respect to S1 and region A, with respect to S1 and region A, whether it is fitting? Yes, it is fitting because all the ones are overlapped with all the ones. Now, with respect to the same structuring element S1, if I put that structuring element over here at location B, then what will happen? Whether all the ones in the structuring element are overlapped with all the ones in the image? No, there is one 0 in the image, right? So that 0 and 1 are not fitting, right? And that is why we will say that structuring element S1 is not fitting with respect to this region B. If I look at region C, once again, what I can say, I am having the structuring elements with all the ones, and in my region C, I am not having the corresponding values, pixel values as ones, right? So, all the pixel values are not ones with respect to the structuring element S1. So, this region, with respect to this region C, I will say that S1 does not fit with C. Okay, now let us see what happens with S2. So, S2 is the cross structuring element, cross shaped, right, and it is of size 3 by 3. So, I am placing now this S2 over A. So, what is happening? I am placing this S2 over A. So, what I will look for? I will look for the ones in the structuring element. So, I am having 5 ones in the structuring element. So, with respect to these 5 ones in this region A, if I look at this region A, this one is overlapped with 1 in the structuring element, right? So, this is a fit. For this one, I am having the overlap. For this one, I am having the overlap. For this one, I am having the exact fit. For this one also, I am having the exact fit. So, I will be simply looking at the ones in the structuring element and the ones, associated ones in the image, right? So, this pattern of my structuring element, cross pattern of my structuring element fits with this pattern, right? So, with respect to this region A, my S2 is fitting, right? So, S2 fits this region A. Okay. Now, if I look at this region B, so I will be putting this S2 at region B. So, once again, these cross elements are fitting with these cross elements of S2, 5 ones of S2. fit with this pattern in region B. So once again, I'll say that S2 fits my B. Okay. Now, if S2 is placed at this region C, then what is happening? I am having 5 ones in S2. So, all these 5 ones I would like to fit with respect to ones in the image region. So, it is not fitting. Okay. So, S2 does not fit with the region C. Okay. So, this is the concept of fitting. Now, let us talk about the hit. So, first of all, let me write the definition for hitting. Okay. So, I'll write it here. The structuring element is said to hit. It's said to hit or intersects an image if at least for one of its pixels set to 1, the corresponding image pixel is also 1, right? So, if I am overlapping my structuring element with the region of the image, then if it happens that for at least one element of structuring element with value 1, I am having the corresponding pixel value also as 1. Okay. So, if at least one match is there with respect to the structuring element value 1 and the corresponding image pixel value 1, then I'll say that structuring element hits the image. Okay. So, let us once again focus upon this structuring element S1. So, this structuring element S1 is placed at region A. Okay. So, structuring element S1 is placed at this region A. So, whether it hits the region A, yes, of course, because all the pixels or all the elements in S1 are ones and these are having overlapped with all the elements in the region A, those are ones. So, there is at least one pixel, yes, all 9 pixels are having the corresponding 1 values in region A. So, obviously, S1 hits region A. Okay. Now, let us see whether S1 hits the region B, whether S1 hits the region B. So, S1 is overlapped with B. So, of course, there is at least one pixel such that S1 is having the value 1 and the corresponding value in region B is also 1. Yes, there are 8 such pixels. So, obviously, this S1 hits region B. Yes. What about C? There is 1 pixel in this region C having the value 1 and S1 is having all the values 1. So, this one, at least 1 pixel is having corresponding 1 value. So, in the intersection of these two C and S1, I am having 1 pixel, okay, having both the values same 1 1. So once again S1 hits the region C. Okay, now what about S2? So let us see what happens with S2. So if I place this S2 at region A, then what will happen? Cross, it is cross, right? Structuring element is cross shaped. So these 5 are ones. So whether at these 5 locations I am having at least 1, yes, all 5 are ones. So once again I will say that S2 hits region A. What about B? I will be placing S2 over here, right? So corresponding to the ones in my S2, I am having there the ones in my region B. Okay, no issues. At least one I want, but here I am having all, right? So I may say that S2 hits the region B. Yes. Now, what will happen with respect to region C now? So I will be putting this S2 over region C. So it is cross shaped, right? So in this cross shaped, I will be having all ones in my structuring element, but no one having the corresponding pixel in my image as 1. So all these 5 pixels are zeros. So with respect to 1 in my structuring element, I am not having any corresponding pixel with value 1, and that is why I will say that S2 does not hit region C. So S2 doesn't hit, right, this region C. So this is what we mean by fitting and hitting with respect to the structuring element. Please remember that 0 valued pixels of the structuring element are ignored. Right? So wherever we are having 1 in the structuring element, we are considering only the corresponding pixel in my image. If the structuring element is 0, I am not at all considering or comparing the corresponding pixel in my binary image. Right? So I hope you must have understood the concept of fitting and hitting with structuring element, and this concept is really very important whenever we go for few fundamental morphological operations, right? So let us proceed with few examples of structuring elements. So see here, we are having various examples of structuring elements, okay, and also we have denoted the reflections of the structuring elements around the origin. Here this X denotes the don't care condition, don't care, right? So as I stated, structuring elements are having either the values 0, 1 or don't care. So this cross indicates don't care. Okay, so see here, I am having this structuring element with this as the origin. So this is my origin, okay, and if I reflect this structuring element, then I will be coming up with this particular pattern or this particular structuring element, right? So what we mean by reflection, we have discussed this operation reflection in our earlier class. So reflection is denoted as B hat equal to, it is the set of pixels W or the set of elements W such that W is equal to minus B for all B's, right, in the set capital B. So this is the definition of reflection. So if we apply this definition of reflection to the structuring element, we will be getting the reflection of that structuring element, right? So, we are showing here all the pairs of structuring elements. Here this light blue or grey shade is indicating the value 1, okay, and the white indicates the value 0. So, grey indicates value 1 and white indicates the value 0, okay. So, in this structuring element we are having all 5 ones, and if we try to find this reflection of this structuring element, what we are getting is this, okay. Now, just go through, this is the structuring element and this is the reflection of the structuring element. This is my structuring element and this is what I get as the reflection. This is my structuring element and what is the reflection B hat that I get is this. If this is my structuring element, this is the reflection. If this is the structuring element, this is the reflection, okay. So, see here the pairs of the original structuring element and the reflection of the structuring element. So, you must have noticed how these reflections are being computed, okay. So, how the reflections are being computed, let us see here. If I am having the coordinate system, here I am having 0, 1, 2, 3, 4 suppose. Here I am having -1, -2, -3 and -4. Here I am having 1, 2, 3. Here I am having -1, -2 and -3. Okay. So, how we are getting this reflection? So, see here, let us assume that this structuring element is being placed like this. Okay. So, this is the origin, that is 0, 0. Okay. So, if I consider the positions of this structuring element, then what would be the positions of this structuring element? Just see here. Just for the sake of understanding, I am explaining all this. So, the structuring element is having now the locations like this is the origin, say 0, 0. Then this is 0, 1 and this is 0, 2. What about this? This is downwards, right? So, this is -1, 0, -1, 1 and -1, 2, and this is -2, 0, -2, 1 and -2, 2. So, this is the original structuring element I have. So, if I try to compute B hat, that is the reflection of that structuring element. Okay. So, here I am having this as the origin. Okay. Now, I am computing the reflection. So, reflection is simply I will be negating. In reflection B hat, I will be having the elements like W such that W is -B. Okay. So, for each of these coordinates, I will be negating these coordinates. So, 0, 0 will be the same. 0, 1 will become 0, -1. 0, 2 will become 0, -2. -1, 0 will become 1, 0. -1, 1 will become 1, -1. -1, 2 will be 1, -2. Then -2, 0 will be 2, 0. -2, 1 will be 2, -1. -2, 2 will be 2, -2. So, this is my reflection. So, see here, if I try to plot this reflection here now, so 0, 0 is this, then 0, -1 0 minus 1. So I'll paint it with different color. So see here, this 0 minus 1. So 0 and minus 1. So 0 0 would be this. 0 minus 1. 0 minus 2. Then 1 0. 1 minus 1. 1 minus 2. 2 0. 2 minus 1. And 2 minus 2. Okay, so this is the reflection that I am getting. Okay, so considering this as 0 0, I am having the reflection. So origin is still this, but the entire structuring element is reflected. So see here, the structuring element is now having the origin over here, and look at the other elements. So this is how we compute the reflection. So I hope you must have understood the concept, right? So we are going to conclude this session. In the next session, I'll be discussing about fundamental morphological operations. Those are dilation operation and erosion operation. So let's conclude the session. Thank you.